Hi guys. Okay, so get your reviews out and maybe have some extra paper out. And let's get started. For these first ones, I'm just going to write the answers down, but make yourself a note. When you're working with real and imaginary numbers, all of your answers need to be written in the form A plus BI. So you have to remember that all of the time. Real plus a real times an imaginary. So it has to be written like that. So the answer to A is -3 plus 4i. And I'm sure a lot of you have 4i minus 3. Well, that's written backwards, so switch it around. The second one, your answer was 14 over 13 minus 18 over 13i. And again, a lot of you may have had this answer all over 13, but you have to separate and write your real number minus your real number times your imaginary. And then your last one here, the answer is, if I'm being really picky, like this for your real and your real times your imaginary, but I will accept this answer, okay? Just make sure that if you had written the answer in -3i over 4, that the I has to drop out of the fraction and just stand next to it, and it's allowed to drop out of the numerator. Sorry about that. Let's figure out why that happened. Let me shut that down really quick. Not sure why that happened. All right, so if you need to finish writing that down, pause what I'm doing because I'm getting ready to erase. Okay, moving on to your composition of function problems. All right, so first thing I want to point out is you're given two functions. Okay, you got your f function, your function of f, and your function of g. Okay, and something that I would also want to point out here is that these two things actually say the same thing. This says f of g of x. Anytime you see, like this says f of x, this says of. Okay, this also says f of g of x. So that and that say the same thing. All right, so when you're doing a composition of functions, and you'll notice that this is an expression, there's no equal sign. What you do is you take your first function that you mentioned, your f of x, which is 3x minus 2, and you pull the x out, replace it with parentheses, and then you go get your second function, which is your g of x, and you replace your x with the g. So you're inserting the g function into your f function wherever x is. Okay? And then obviously you need to simplify this. So you may be wondering, well, what do I do here? I get 3 times this fraction. Well, just turn your 3 into a fraction. Multiply and multiply 8 minus 2. And that's all you can do. No equal sign up here, so nothing left for you to do. Now when we go over here, you do have an equal sign, and you've already done this part. You did it right here. Remember how I told you that f of g of x says the same thing as this. So what you're going to do is you're going to take, sorry about that, you're going to take 3x over x minus 5 minus 2, and you're going to set it equal to -10, and you're going to solve it. So we're just going to solve for x by moving the 2. And that gives you 3x, x minus 5 equals -8. And then you've got two options at this point. You got an x in the numerator and the x in the denominator. So you've got to get this out of the denominator. Denominators, remember how picky they are. Well, to move this quantity to the other side of the equation, or to get it out of the denominator, what you can do is you can, instead of dividing, use the opposite, use multiplication, and you can cancel that out. And then on this side, you can multiply that times your 8. So that gives you 3x equals negative 8x plus 40. And then we're just going to move the 8x over by adding 8x. And that gives you 11x equals 40. And just divide the 11. And that's what you're asked to do. Okay? Got it? All right. And then the last one, again, pause if you want to write this down because I'm going to erase all this to have lots of room to do my inverse function. So pause. All right. So now we're going to look at our inverse function. I gave you some notes that I typed up on doing inverse functions. And this has to do with this equation. That doesn't and no G's. Okay, so what you do was you write down your equation, f of x equals 3x minus 2. And because we're doing the inverse function, first we're going to replace this f of x. Remember, it always equals y. And then to do the inverse, this little -1 right here tells you to do this thing. You're going to switch these two terms. So the x is going to come over here and the y is going to come over here. So the x and y's are going to switch spots. But you still have to solve for y. So we're going to add the 2 and slide it in right there. X plus 2 equals 3y, and then we're going to divide the 3 off. So you get y equals x plus 2 over 3. And then what you've got to do is you're going to plug a 5 in for your x. And give me 1 second. I'm going to pause for a moment. Okay, and I'm going to bring it back. So now all we have to do, now that we have solved for y, we switch the x and the y, and we solve for y, we're going to plug the 5 in for our x, because remember the number for x is always in the parentheses. So we're going to replace the x with a 5, and that gives us 7/3. So the inverse function of a 5 gives you 7/3. And that's the answer for that one. Okay, so why don't you pause for a second and write yourself some notes so that when you're taking the exam on, whatever day you're taking the exam, you can remember when you're doing the inverse function, those quick little steps. Change it to y, change the f of x to y. Then you're doing the inverse, so switch the x's and the y, then solve for y, and then plug the number in for x and solve. Okay? Pause again because I'm getting ready to erase. And moving on. All right, so the next one here, I imagine most of you don't have a problem with this one. You're just trying to figure out what numbers goes here. So the rule is you're going to use the square root property. First, you've got to isolate your square root. So you're going to move the 4, and that gives you x square root of x plus 12 equals 12. And then remember, just to get rid of a square root, you do the opposite. And if you square one side, you square the other. So x plus 12 equals 144. Move the 12. X equals 132. And then you should check it to make sure you're right. So if you got 132 plus 12 plus 4, you should get 16. So this gives you, what's 132 plus 12? 144 plus 4 equals 16. And the square root of 144 is 12, and 12 plus 4 equals 16. So check you did it right. Again, pause if you need to continue writing. I'm erasing now. All right, so now we're going to get to some of our graphs. And this one here, actually on the test, this one's graphed for you, but we're going to go through the motions anyway. And then I'm going to explain something that's going to make this part pretty easy to do. And you're definitely going to take notes. If that didn't make sense, you're definitely going to want to take notes. All right, so first you've got to be able to graph these two. So we look at your linear equation. We know it's linear because your x and your y are to the first. We also know it's diagonal because it has an x and a y. you're going to put it in slope-intercept because that's the fastest way to graph an equation. So we're going to take the 3x, subtract it, and slide it up front. So negative y equals negative 3x minus 6. Divide the negative. So you got y equals 3x. And you can use the over 1 for your slope, plus 6. So let's go graph that. Let me make my pen a little bit smaller. So we're going to go up 6, put a point, and then you've got your slope here. That's your y-intercept. There's your slope. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. 1, 2, 3, run 1. And you can also reverse it. You can do negative 3 over negative 1 as a slope. So down 3 and left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. Now you can graph your line. Let me get a really skinny little line here. I'll do my lines in purple. Okay, so you have your line there. All right. Did I graph that in? Let me get that in the right spot. Oh my goodness, let me slide all those points over. I don't know. Oh, I got it. Okay, so it's perfect. It was weird what my computer just did. All right, so that gives you your linear equation. Now, you've also got to be able to graph this parabola. What I want you to notice here, let me fatten my pen up a little bit, is that, oh, that's going to be too fat. Hang on. Thank you. There we go. You have, if you recognize this, if I just show you this, that's your parent function. And then you're adding 2. Well, anytime you're graphing a parabola, unless you really know parabolas, you've got to start off with your vertex. So if we wanted to graph that, we're going to use our formula for vertex. So you'll recall that your vertex formula is, I'll write it over here, vertex. You guys should pretty much have this memorized. The opposite of b over 2a, and then the opposite of b squared over 4a plus c. So we're going to look at this information. Your a is 1. Your b is not even here, so it's a 0. And your c is 2. So if you were to go and plug all of that information into your vertex formula, the opposite of 0 over 2 times 1, well, that's just 0. And then the opposite of 0 squared, pretty much you could be done with this, plus c, which is 2, gives you 0 plus 2. So your vertex is 0, 2. Right? So that's your vertex of your parabola, and then it's your parent function. But if you're concerned about knowing what to graph, I don't know if you remember or not, but when you're graphing your parent function of a parabola, you go left 1 up 1, right 1 up 1. So we'll pick negative 1 and positive 1, and left 2 up 4 and right 2 up 4. So we'll plug those 4 points in to our formula right here. So let's plug it in right here. So we'll go y equals negative 1 squared plus 2. That's 1 plus 2. That gives you 3. So we're going to go negative 1 up 3. Ooh, that's nice because that's going to give us an intersection on 1 point. And if we plug in the 1 squared, we get 3 as well. So right 1 and up 3. Now you can see your line of symmetry is right here down the y-axis. When I move this, it'll go back to where it's supposed to be. All right, and then let's plug in a negative 2. So if we were to plug in a negative 2 right here, you get negative 2 squared, which is 4, and 4 plus 2 is 6. So we're going to go left 2 and up 6. And you know that it can reflect, oops, over right there. Okay. And so those are your points, just in case you're concerned about your graph. So I'll go graph that. Your parabola is coming down, cruising up. And don't trust my graph here because I obviously didn't draw a perfect parabola. Okay, but you've got your vertex. It's right there. It's your minimum. Let me get a different color. It's your minimum. It's supposed to open up because your A was positive 1, and it's the parent function, so it's vertex left 1 up 1 right 1 up 1. Remember that because it's going to be on the test. All of your graphs will be parent functions. Your vertex will just be somewhere different. Okay, and then you got your find your y-intercepts of both graphs. So let's take a look at our slope-intercept. For our linear equation, our y-intercept is here, so it's a 0, 6, and we can see that. It's right there. And for our other graph, our parabola, here's our y-intercept at 0, 2. So we've got that taken care of. Then we have to determine the coordinates where the two graphs intersect. We can see this one right here. Tomorrow, you're going to have a graph. These are going to be graphed for you, or on the test, these are going to be graphed for you, but there won't be a grid behind them. It'll just be a picture like this, and you'll have a parabola and a line, and you have to determine these, and you can't just guess where they are because it'll say that the picture is not to scale. So you can't just guess. We've got to have a way to actually determine where these intersections are. Now, I've already told you that one of those intersections, I graphed both of them, was negative 1, 3. That was one of the intersections of the two graphs, but we've got to find the other one, and tomorrow we're not going to know, or on the test you're not going to know any of this given the picture, so you're going to have to do everything mathematically. All right, so you have all of this information written down. If you don't, stop and write it down because I've got to erase. Okay. And we're clearing that out. Let me go and put my parabola back in really quick. All right, and so now I'm working on where the two graphs intersect. And if you'll recall, our linear equation was y equals 3x plus 6. And our other equation, y equals x squared plus 2. You'll notice that both of these equations are solved for y, which means that y, I can replace this y with this information right here. I can take this and replace the y with that because they both equal y. So that means that they can equal each other. So mathematically, this is a really quick way to determine where the graphs intersect. So what you got to do is you see this is a quadratic. What we're going to do is we're going to combine like terms, make it equal 0, factor it out, find the zeros. So let's move the 3x and the 6 over here. The 3x we're going to slide in the middle. The negative 6 will just combine there. So that gives us x squared minus 3x minus 4 equals 0. And if you use your quadratic, plug it into quadratic to find your zeros. If not, you know, factor it out. Everything on the test pretty much is factorable. And I think a negative 4 and a positive 1 will work. So you get this. X minus 4 and x plus 1 equal 0. And then we've got to find our zeros or our intercepts. So x minus 4 equals 0 or x plus 1 equals 0. So you get x equals 4 or x equals negative 1 when you move those numbers over. All right. So now what that means is that for x equals 4, I can plug that into both of these equations, and it'll tell me what my y is. And watch me get the same number twice. I'll do it over here. So if y equals, I'll do the linear. If I plug in a 4 plus 6, and then I do the same thing for my parabola. If I do 4 squared plus 6, watch what happens. I get y equals 12 plus 6, or y equals 18. And over here, y equals 16. Wait, hang on, that's a plus 2. Ooh, plus 2, plus 2. Okay, plus 2, I get y equals 18. So for both of these graphs, they had a plug in a 4 for your x, and they both got out an 18 for their y. So that is one of their intersections, where they're going to intersect. So at negative 4 up 18, right here, this parabola should be crossing right there. And again, your graph is not going to have any grid behind it. So you've got to do the math to prove it. And then you go back and you plug in the -1 in both equations. So if I plug in a -1 right there, that would give me -3 plus 6. So y equals 3. And then if I plug it in over here, a -1 squared plus 2, that's 1 plus 2 equals 3. So if I plug in a -1, I get out a 3. And you guys can see that intersection right there. We proved that earlier. So that's how you find their intersections. You set the two quantities equal to each other, write it as a quadratic, factor it out, find your zeros, plug them in. Okay? All right, then we go back to the easier stuff. Again, write it down, pause. I'm erasing. I'm going to erase so I don't erase my picture. Let me grab a fat eraser. All right, so last two things you've got to be able to do here are to find the slope of this equation here. Well, we already wrote it. It was 3x plus 6. So your slope is 3. And then it says find the slope of the line perpendicular to that. So remember that perpendicular, you flip it over and you change the sign. So the slope of the perpendicular line is -1/3. Okay, so you'll have those. Moving on to the next question. I'm erasing. And we're going down to the next question. All right, for this one here, what you were asked to do was draw a triangle. So I'm going to grab a triangle here real quick. And I'm going to make it at least look a little bit like it should. All right, and it says label the dimensions of each side. X squared minus 34, x plus 6, and 2x respectively. So I'm going to do x squared minus 34, x plus 6, and 2x. And it says label their perimeter of the triangle is 42 units. So that means if I add that plus that plus that, it should equal 42. So let's set that up. X squared minus 34 plus x plus 6 plus 2x all equals 42. So that takes care of those two. And then it says write down a quadratic to show x in this information. So I've written it down, but it doesn't look like a quadratic because remember quadratics have to look like this. Ax squared plus bx plus c equals 0. So I've got to do some combining and get the 42 over here. So the x squared, we're going to do x and 2x is 3x. Then negative 34 plus 6 is negative 28. And then again, it has to equal 0, so we'll subtract the 42. And we get this. X squared plus 3x minus 70 equals 0. Okay, and then it says solve the quadratic. So either you're going to plug it into your quadratic or you're going to factor. Okay, so remember you can do either one to find your zeros and to find your x, right? I think it's going to factor nicely. Two numbers that multiply to negative 70 add to 3. Those are the numbers I find. That gives me 10x and negative 3x, so that works. So we got x plus 10 and x minus 7 equals 0. So set them both equal to 0. So you get x equals negative 10 and x equals 7. So that's solving the quadratic. Now it says, last question, big question, the one that makes you think, why would there only be one possible solution for x? Well, let's go ahead and plug this negative 10 in right here. Negative 10 squared minus 34 gives you 100 minus 34. Well, that's possible. Let's plug it in here. 2 times negative 10. That gives you negative 20. Possible for an answer or a side of a triangle to be a negative measurement? Absolutely not. But it could be positive. 14, that will work. 13, that will work. And 49 minus 34, that will work. So 13, 14, 15, this is the only one that'll work. Okay, I'm erasing. moving on. Or this video is going to be crazy long. All right. Do you need me for something? Yep. All right, and back to our video here. What we have to do is, with number 6, is take our quadratic and do the following. Find our roots or find our x's. So we're going to solve that. We're going to find the vertex, not hard. Find the line of symmetry, not hard. Find the y-intercept, totally easy, and graph. Okay, so we're going to just go back to quadratics. So we're going to change the y to a 0 because quadratics, that's what you do. Okay, and let's identify what we know already. If your a is 1, that means it's your parent function. Okay, your b is -2, and your c is -15. So let's find our intercepts. So first let's go and just factor this out, or use your quadratic, whatever you do. I factor because I prefer factoring. -5 and 3 gives me -5x and 3x, which gives me what I want. So x minus 5 and x plus 3 equals 0. So by now you should know x equals 5 and x equals -3 when my y equals 0. Remember, I replaced the y with a 0. So I'm going to go to my graph to x equals 5, 0, and put a point. And I'm going to go to this point, -3, 0, and I'm going to put that point. So you know that my line of symmetry, or my vertex, is going to be halfway between these. So they're 8 apart. So I'm going to go 4, 1, 2, 3, 4. So I bet you anything that this is my line of symmetry. Okay? All right. So now let's go find our vertex using our formula. You already wrote it down. So let's plug it in. The opposite of -2 over 2 times 1. So that's 2 over 2, or 1. Okay, 1. Wow, that's interesting. Let's go do the opposite of -2 squared over 4 times 1 plus -15 to get our other point. So the opposite of 4 is -4 over 4, and that gives us -1. So -1 minus 15 is -16. So our vertex is 1, -16. So we're going to come over to 1, go down 5, 10, 15, 16, and we're going to put a point. So there's our vertex, and that's what I predicted was going to happen with our line of symmetry. So our vertex is -1, or 1, sorry, 1, -16. And our x's, or our zeros, were -3, 0, and 5, 0. Now we're going to find our line of symmetry. This is a vertical line. Remember that vertical lines don't have y-intercepts. So if this is my vertex, then my line of symmetry is x equals 1, because it doesn't have a y-intercept. My equation doesn't have a y. So my line of symmetry. And then it says find the y-intercept. Well, that's easy to find. Our y-intercept is here. So we know that it's got a point there, and it'll mirror across the y-axis. And you know, that really is enough to graph your parabola. So we'll cruise up that direction, and we are done. Okay, moving on, I'm going to erase. And we're almost done. 2 more problems. Here we go. All right, so now we have our cubic function. Always fun. So first we're going to use synthetic division, or factoring, or the quadratic. So first let's see if we can factor it. Let's cut it in half. What they have on this side is x squared, leaving us with x minus 2. And I don't see anything on this side that will leave us with that. So we can't factor. So we're going to have to do our synthetic division to find our first factor. So remember that you write all of the factors as 6. And I'm going to start with 1. And I'm going to write the coefficients and use synthetic. All right, so my first factor was x minus 1 because it's always the opposite of that. So that's my first factor. And then I'm going to take my leftovers, x squared minus x minus 6, and I'm going to find my other two factors, so x and x. And I bet negative 3 and positive 2 will add up. So this gives me x minus 3 and x plus 2. And they have to equal 0 if I'm finding my zeros. So x minus 1 equals 0, x minus 3 equals 0, and x plus 2 equals 0. So that's x equals 1, x equals 3, and x equals negative 2. So I'm going to go graph those now. So 1, 3, and negative 2. Okay, and so that takes care of that. Then it says create a table and find the y value for each of these points here. Now I'd like to talk about why we chose negative 3 and 4. Well, if this is negative 2, if we have negative 3 plugged in, then we can figure out how far down or how far up this is going. If it's going to come up, hit a point, come down and go up, or if it's going to come down, hit a minimum, come up, hit a maximum, and come down. So that's why we picked those points. So let's plug those in. So if we do an x and y, and we plug in a negative 3 and a negative 0.5 and a 2 and a 4, and we plug those into our equation up here. Let me make some space. So I'm going to erase this. So pause if you need to write it down. All right. And then what we're going to do is, some of you, when you took the test, really messed up on this part right here. So let's make sure that that doesn't happen again on the test. I'm going to go plug in negative 3 in for x. So you've got to make sure that anytime you replace a variable with a number, you use parentheses. And also you always have to remember to use your order of operations. So when I solve this problem, the first thing I've got to do is my exponent work. So negative 3 times negative 3 times negative 3. That's 9 times negative 3, so negative 27. And then minus 2, and negative 3 times negative 3 is 9. Okay, minus, I can do this math now if I'm ready. So negative 5 and negative 3 is positive 15 plus 6. And then I'll go back and do this math right here, which gives me negative 18, and I'll just cancel that out. All right, so here, something else that makes life easy, when you're adding and subtracting positives and negatives, if you put your negatives together and your positives together first, then you can just subtract what you get. So I think here this was going to give us negative 45. That would be 15, carry the 1, yes. And this is going to be positive 21. So now I'm going to subtract those two, and that's going to give me negative 24. 45 minus 21, yes. So negative 24. So that means that I'm going to go down from left 3 and down 24, so it's going to be way down here. Okay, so now I know it's going to come up, hit a max, come down, hit a min, and go up and hit a max, okay? Now I'm going to go back and I'm going to erase all of this data, and I'm going to plug in my new data. Okay, so now I'm going to go and plug in the half, the negative half. Now, why did we choose negative half? If you go and look at these 2 points, I'm going to graph a parabola between them, and they're 3 spaces apart, 1, 2, 3. So to go halfway between them to find that vertex, or where it's going to hit its top or its maximum point, I've got to go half of 3, which is 1.5. So that means I'm going to go 1.5 spaces, and that's that spot right there. So that's why we choose that point. So we're going to plug in negative 0.5, negative 0.5, negative 0.5. And you've got a calculator, so you need to do negative 0.5. You can caret 3 if you want. So that's going to give me negative 0.125. Check my math. The negative 0.5 and 0.5 is 0.25 times 0.5. Yep, 125, negative times negative, and then 1, 2, 3 decimal places. All right, and it's a negative because negative times negative times negative. And then here, I'm going to do negative 0.5 times 0.5, so that gives me 0.25. Negative times negative is positive, so I'm going to go minus 2 times that, and then I'm going to multiply this, so 5 times 0.5 is 25 with 1 decimal place, so negative and negative is positive, so plus 0.25, and then plus 6. So I need to do this math right here. Hang on a second. Negative 2 times 0.25. So I just need to do that. So 2 quarters is 50 cents. So we're going to have negative 25 minus 0.50 plus 2.5 plus 6. And again, I suggest you combine those. So that would give you 8.5. Remember to think of it kind of like money. That's $2.50 and $6, so that's $8.50. And over here, you're going to add those. So you're just going to line it up and combine those. So that gives you negative 0 point, and we're adding 6 to 5 plus 8.5. So now I have to subtract these, and you probably have your calculator, but I'm going to go ahead and do the math here. Okay, since I'm subtracting, since this is positive and that's negative, borrow from the 5, make that a 10 to borrow again. So 5, 9, 7, and I'm going to have to borrow from the 8 to make that a 14. So 14 minus 6 is 8, and 7 minus 0. I bring down your decimal. So this is 7.875, and hopefully my math is right. So that means I'm going to go up 7, almost up to 8, and I'm going to put that point there. So now I know that this is going to come up, hit that point, and come down. Now, here's why we picked 2, because 2 is smack dab between those 2 points. So you go back and you're going to plug your 2 in for all of these spots, and you're going to do it all over again. And again, you guys have calculators, so it'll be a little faster. I'm giving you time to do your math. So we're going to plug a 2 in, a 2 in, and a 2 in. So 2 cubed, that's for 8, and 2 squared is 4, so negative 2 times 4 is negative 8. Well, that's nice, that canceled that out. And negative 10 plus 6 gives you negative 4. So that worked out a little faster. So 2 down 4, and that gives you that, your parabola here. So get that little guy drawn in. So you kind of have this nice little graph here. And then we got to just put the 4 in so we know how high this is going to go. So we're going to plug the last number in, and then we'll be done. And this is probably the one that takes the most time. So 4 cubed minus 2 times 4 squared minus 5 times 4. That is a minus, right? Plus 6. So 4 cubed, 16 times 4 is 64. 4 squared, negative 2 times 16 is negative 32. I'm going to do that math right there. That gives me 32. And this is minus 20. So minus 20 gives me 12 plus 6 gives me 18. So 4 and up 18. And that gives me that point right there. And now I know what my end behavior is like and what my graph would look like. Okay? And so that's graphing a cubic. There's nothing easy about it. It's hard from beginning to end. But good job. And I'm getting ready to erase, so pause if you need to. All right, last one. Let's see how you do on number 8. Okay, so number 8, pretty easy one actually. Something that we just did. I'm going to scooch this over a little bit. All right, so it says, let me scoot it up a little bit. So given the following graphs of lines A and B, find the equation of the line through -1, -5 parallel to A. I actually like to change this to -2, 5, because if I plug this point in parallel to this, it actually is on this line right here. This is -1, 5, and if it's parallel to this line, oh, this line, oh, line A, never mind. So we're going to leave it. Forget that. Okay, so here's line A right here. And this is, hang on a second. Let me see if I just moved things when I moved my graph. I did, huh? I did. This is line A and line B. All right, so again, sorry. So let's change it to -2, 5. Okay? So parallel to A is this line here. So let's put our point at -2, 5 right here. And if it's parallel, that means it has the same slope. So let's find the slope of line A from point to point. That's down 1, right 1, right? So we're going to go down 1, right 1, down 1, right 1. And you know, it's probably pretty simple to, oh, I can't graph. I'm going to have to just draw my line. To draw your parallel line in there. And you can see your y-intercept no problem. So if you had to write the equation, you could see it. So it's y equals, what's your slope again? Down 1, right 1. So your slope is down 1, right 1, x. And then your y-intercept is +3. So y equals -x plus 3. Now if you don't have a graph, you know that you can always take your slope and your point, and you can plug it into point slope. Distribute y minus 5 equals -x minus 2. Add the 5 over here. Y equals -x plus 3, which is what we came up with. Now, if we were asked on the test to write it in standard, you would have to take the x and slide it over here. So you may have to write it like that. Okay? So that's that one. Now it says find the equation of the line through -2, -4 perpendicular to B. So let's go find, I'm going to erase. So let's go find the slope of B, and then let's do perpendicular to that. So the slope of B, let's just pick 2 points on there, is a rise of 1 and a run of 1. So the slope of 1, perpendicular, flip, and from negative to positive, or from positive to negative. Remember that they should multiply to give you -1. So the perpendicular slope, the slope that you need here, you got your point to -4 with a slope of -1. So you plug that into your point slope. Remember, it was minus -4, which is why I wrote +4, by the way. So y plus 4 equals -x plus 2. Move the 4 over. Y equals -x minus 2. And that's your slope-intercept. If you have to write it in standard, take the x, move it over here. X equals y. Plus y equals -2. So there's your two equations, depending on what you're asked. So it says find the slope of a line parallel to A. Well, we did that a long time ago. Parallel to A was a negative slope, so, and it was -1 and 1, so -1, that's the slope. Perpendicular to B, that was +1 and 1. Perpendicular, we flipped and changed, so that was -1. And that's all you got to do. So have a good day. Hope you study. Be ready. Bye.